Hello everyone, this is Dr. Webster, and we are doing a paired sample t-test, conducting and interpreting a paired sample t-test in SPSS, and I'm in the bot survey again, and here we are going to redo the Check Your Learning exercise example where we are looking at whether people are reporting more anxiety about doing math or being more anxious about taking the stats course, the stats course. And so we are going to, again, go to Analyze, and then just like for the single sample t-test, then we're going to go to Compare Means and Proportions, and here we see the paired sample t-test option, so we'll select that, and then we'll get a prompt, right? And then we want to select the two outcomes that we are comparing, right? Because we have one sample, two different outcomes here from that one sample. And so we're comparing, again, anxiety about stats, anxiety about math, oops, just stats, math, right? So you want to select the two outcomes that you're comparing and then bring those over. And then we are going to click here where it says calculate standardizer using, and then you're going to click average of the variances. So this will, SPSS will calculate the pooled standard deviation in order to calculate Cohen's D. There are other options here, and we would go into the, if we were in a more advanced stats class, we would talk about why, I would argue why it's better to use the pooled standard deviation here. But that's what we're going to do for this class, right? So, and that's it. That's all you need to do in this window. So we'll paste our syntax, right? And then we'll appear in your syntax window. So go ahead and just highlight and then run that. And so you'll get 4 different tables here in your results. One of these tables we did not look at in the Check Your Learning exercise, and when we did the example looking at prejudice towards feminists and prostitutes, we also didn't look at this table. So it's the paired samples correlation table. We don't look at that. So I am just going to delete that for our sake. So it's just out of the way, and we are left with the 3 tables that we took a look at for the Check Your Learning exercise. And yeah, so first table has our descriptive statistics, looking at the mean score for stats anxiety and math anxiety. And then we notice our N here, which is 198, and there's one big N here, right? Because we have 198 responses for each outcome here, right? Because it's one sample, 2 different outcomes. So we see that the N's match, and then we have the standard deviation for each outcome. And then we have the t-test, the t-stat table down here, and then we have our Cohen's D in the 3rd table. And as I discussed in class, the equation and formula for a paired sample t-test gets exponentially more complicated. The single sample t-test is just relatively just so simple, and then we get to the paired sample t-test and it just gets so complex. So, but to calculate any inferential value, we take the mean difference divided by error, right? What's the observed difference, and is that observed difference, right, big enough, far away enough from 0 to indicate a true and real difference? And so in this case, right, we're looking at the mean difference between stats anxiety and math anxiety, and we find that mean difference down here in the t-test table where it says mean. So this is the mean paired difference here. I know it's sort of confusing that the column says mean, but this is the mean difference. So this is 4.6 minus 3.29 gives us 1.31. So that's the mean difference. And then the error term here, which is right here, the standard error here, because again, these are estimates, right? These mean scores are estimates of what's going on in the population, right? We're using the sample to estimate what's going on in the population, so we'll always have error. And so we take that mean difference divided by the error, and that gives us our t-value here, which is 6.78. right? So we calculated the SPSS calculated the inferential value, and then using the degrees of freedom here and the inferential value, the t-value, right? SPSS finds the p-value, and we see here the p-value is less than 0.001. So this is we're seeing the same p-value pop up over and over again. We'll see other p-values, I promise. But we have less than 0.001, right? So it's the p-value is pretty small. It's like 0.000056739, something like that, right? And just like the other examples where we've seen this p-value, we do have a significant difference, statistically significant difference, because our p-value is less than or equal to our threshold of 0.05. So again, we are 99.9% over 99.9% certain that the observed difference here is a real and true difference. It's far enough away from zero to indicate a true and real difference, right? And so to get that percentage, right, we do 1 minus p times 100 in order to get that percentage. And I chose to do this example for the paired sample t-test because we have this math anxiety question, which is a reverse coded question, right? Because we have a negatively worded question here because we have, I do not get anxious thinking about math and algebra problems, right? So this is a negatively worded item, a reverse coded item, because we have the word not in here. So for stats anxiety, the stats anxiety item, higher scores indicate greater anxiety about taking the stats course, right? So higher scores, greater anxiety. For the math anxiety question, higher scores actually indicate less anxiety because of the not, right? So it's actually lower, right? Lower scores on the math anxiety question actually indicate more anxiety. Lower scores on the math anxiety question indicate more anxiety because we have the word not. So you see that the mean score, 3.29, right, is lower than the stats anxiety mean. But this actually indicates, this actually reflects that people are more anxious about math than they are in taking this stats course, right? Math is freaking them out a little bit, or well, we'll see. Take a look at Cohen's D down here, but people are freaking out more about, more anxious about math than actually thinking about just taking the stats course. How big is this difference? Well, if we look down here at our Cohen's D table, right? So we have, Cohen's D is mean difference divided by, for the paired sample t-test, it's mean difference, so 1.31, divided by the pooled standard deviation, so the average of the standard deviations for each outcome, right? So SPSS is pooling or averaging the standard deviations for each outcome here to create a pooled standard deviation here. So if we take 1.46, 1.73, do an average of those standard deviations, we'll get 1.6, essentially. So the standardizer here, the number in the Cohen's D row under standardizer, that is the pooled standard deviation. And so SPSS has taken the mean difference divided by the pooled standard deviation, and that gives us our Cohen's D value of 0.82. And according to Cohen, 0.82 is a large, right, large difference. Anything 0.8 and above is a large difference, and medium and large differences should be important. So this seems like it should be a meaningful difference, right? And this is why I try from the very first day of class to sort of ease your anxiety about how much math is going to be involved in the class. And of course, we have done math, right? But hopefully, it's not as much math as you think that we would be doing, right? So it seems like people are much more anxious about doing math, than just in general their feelings, how anxious they are about taking this statistics course. So that is the paired sample t-test in an SPSS, conducting and interpreting a paired sample t-test. So yeah, thanks for listening.